Hello students, in this video we shall discuss a divisibility problem from mathematical induction. So let us see our problem. Show that 49 power n plus 16n minus 1 is divisible by 64 for all n belongs to z plus. Z plus means set of all positive integers. Okay. So let us take our statement as Sn. Let S of n is equal to 49 power n plus 16n minus 1 is divisible by 64 for all n belongs to z plus, that means set of all positive integers. So this is our statement. We can take it as Sn. Okay. Now we have to prove this by the principle of mathematical induction, and we know that in mathematical induction we have 3 steps procedure. So let us see. Case 1, to prove for n is equal to 1, that means we have to prove this statement is divisible by 64 for n is equal to 1. So let us see that S of n become S of 1, that means replace n with 1. So 49 power 1, that means 49 only. 16 into 1, that means 16 only, minus 1. 49 plus 16, 65 minus 1, 64. So we can write it as 64 into 1, that means 64 is divisible by 64 for one time. Okay. So that therefore it is true for n is equal to 1. It is true for n is equal to 1. Okay. Next, case 2. Let us assume it is true for n is equal to k. It is true for n is equal to k, comma, k is an integer. Okay. Our statement is true for n is equal to k, that is our assumption in case 2. Therefore, S of n become S of k. The statement is like this: 49 power k plus 16k minus 1 is divisible by 64. Okay. For all k belongs to z plus. Okay. So this is our statement in case 2. So 49 power k plus 16k minus 1 is divisible by 64. So how many times it is divisible by 64? In case 1, 64 is divisible by 64 one time. So in this case 2, 49 power k plus 16k minus 1 is divisible by 64 means how many times? How many times it is divisible? We don't know that because it is a form, it is not an exact number. Okay. So we take like this: 49 power k plus 16k minus 1 is divisible by 64 for m times. Okay. So the representation is like this: 49 power k plus 16k minus 1 is divisible by 64. How many times? For m times. Okay. So that is our assumption. So from this we can write it as 49 power k minus 16k, plus 16k minus 1 is equal to 64m. Okay. So let us see continuation. So we have to assume 49 power k plus 16k minus 1 is divisible by 64 is equal to m, means it is divisible by 64 for m times, and we can write it as 49 power k plus 16k minus 1 is equal to 64m, and transposing these two terms 16k and minus 1 to right side, then we get 49 power k is equal to 64m minus 16k plus 1. So considering it is as equation number 1, so let us see case 3. Okay, continuation, case 3. Case 3 means let us prove it is true for n is equal to k plus 1 also. It is true for n is equal to k plus 1 also. So that is case 3. So let us take s of k plus 1. S of k plus 1 means 49 power k plus 1 plus 16 of k plus 1 minus 1. Okay, and in this case we have to prove this is divisible by 64. Okay, so let us see how to prove this. 49 power k plus 1 can be written as 49 power k into 49 power 1. Power 1 means it is nothing but 49 only. A power m plus n, a power m into a power n. 16 of k plus 1 means 16 into k, 16k, plus 16 1 just 16 minus 1. Okay, so replace 49 power k by its value. 49 power k means 64m minus 16k plus 1. So substitute that value, 64m minus 16k plus 1 into 49 plus 16k. 16 minus 1 means 15 we get. Okay, now we will multiply these two. So 64m into 49 minus 16k into 49 plus 49 1 ja 49 plus 16k plus 15. And what about these two terms? These two are similar terms because both are containing 16k. Both are containing 16k. Here how many 16k's are there? 49 16k's are there. Here only one 16k is there. This is plus and this is minus, so take subtraction. So 49 minus 1 means 48. That means we can write it as 64m into 49 minus 48. Okay, so largest number have negative sign, so minus 48 into 16k plus 49 plus 15 gives 64 again. Okay, suppose we have to assume like this, 16k is equal to some x. Okay, then we have these two terms like this, minus 49x plus x. Let us suppose 16k as x, then we have minus 49x plus x. So what is the addition of these two terms? We get minus 48x. Okay, that's why I can write like this, minus 48 into x means 16k, and this can be written as 64m into 49 minus 48 can be written as 12 into 4 into 16k plus 64. Okay, continuation. Here 16 into 4 means 64. So take 64 as common, we get 49m. So we take 64 as common from all the terms. Okay, here 64 is there, 16 into 4 also 64, here 64 is there. So take 64 as common, we get 49m minus 12 into k, 12k plus 1. minus 12k plus 1. And what about this number? So it is also an integer, okay? So 64 into some integer. So 64 into maybe some t, okay? So therefore we can express s of k plus 1 like this, 64 into t. That means s of k plus 1 is divisible by 64 for how many times? T times, okay? So that is the proof, okay? Therefore it is true for n is equal to k plus 1. It is true for n is equal to k plus 1. Hence it is true for all values of n by the principle of mathematical induction, okay? Thank you.